Good afternoon, everyone. We have an exciting presentation today around the 3 pitfalls for ML model failure. I'm joined by Duncan Curtis, who is going to be leading us today. He is Sama's SVP of product and leads a team that is developing innovative products and solutions to power AI and ML technologies. So Duncan, I will hand it over to you.
Thanks very much, Lisa. Appreciate it. Hi, folks. So today, as the topic of the webinar is, we're going to talk about some of the pitfalls of ML and what to do about them. And let's start with this core fact. The majority of data scientists, this isn't like a business case study. This is the actual AI and ML teams say that over 80% of their models failed to be deployed. I mean, that's huge. And so, let's look at a couple of those pitfalls and what we can help you do or what strategies you can take to actually have a better outcome. So pitfall number 1 is not annotating your data strategically. So one of the examples here is, or one of the strategies is that you can have too many incorrect examples, which can prevent your model from learning from the signal. So we do believe that you should actually have some incorrect examples, meaning that when you're looking at an annotation strategy with your partner, or if you're annotating internally, is that don't aim for 100%. It's going to cost a lot of time and a lot of effort in order to be able to get to exactly 100%, but you should be certainly aiming for a 95% as a minimum. And then depending on your use case, you can really play with that variability to make sure that you're getting the outcomes you need most efficiently. But you want to make sure it's still quite high so that you can make sure that you're still getting the right signal. Now, you should also consider across different classes. So don't look at this just on a global basis. You want to look at it for each class of object that you're having annotated as well. Secondly, is you want to know what data will have the biggest impact on your model. So this is really about what data set do you have. You want to look at what you're collecting, and you want to make sure that it's representative of the data that you select to annotate. So one of the things we look at is what's the diversity of your data? So an example in autonomous vehicles might be, hey, do I actually have a good representation of nighttime and daytime data? And what about rainy data? And what about data in the early morning when there's glare in the camera? You want to make sure that the data you've collected, or at least the data that you're sampling for your model development, is actually representative of the use cases that you're going to be seeing. For example, if you could annotate, say, 100,000 images for your model, if they're all daytime images, then your model is not going to be performant at night. And it's really not cost effective to annotate all of your data. So you do want to sub-select down as much as you can to still be performant, but you want to get that diversity in your core data set as well. Now, I've talked a little bit about the data, but one of the other sides you want to consider is actually your edge cases. So when you're thinking about the model that you want to produce, is that it's great to start with a list of assumed edge cases that you're going to have. These are the things that you commonly think of that would be rare cases, things that your model is likely to encounter. But one of the things you should be open to as well is that as your annotation partner is going through, or your internal team, as your data is being annotated, other edge cases can actually be identified. And so what you want to do is, once you've got those edge cases identified, is that you want to make sure that you've got a diverse mix of the data of your previous data to go back and look for more instances of that edge case. Once again, when we're talking about the diversity of your data, is that applies to edge cases as well. You may need to do another data collection run, or maybe use synthetic data or augment your data in order to get good representation of that edge case so that you can make sure that your model is actually robust at handling it. So the second pitfall is that you can have poor quality or inefficient annotations. So one of the things that can lead to this is sensor noise, which can really result in low quality and increased effort. And remember, our goal here is to try to get the most high quality annotations for your model as efficiently as possible. So here, what we're looking at is this is a point cloud. So this is a van, as you can see here, and that van's not moving. And you can see the extra frames are being added here. This is as an autonomous vehicle is driving past this van, it's collecting more and more data about that van. Excuse me. What you can see on the left here is that there's actually drift across each frame. And so when we look at that object across multiple frames, it actually drifts to the side. We can, excuse me, just one second. So it drifts over to the side. And if I was going to annotate that, I would actually need to move the cuboid in every single frame to be able to say that I've accurately annotated that. What we've done here with our platform on the right is we've actually taken into account this drift and corrected for it so that we can annotate it one time and be much more efficient in the annotation process. Ooh. Next would be inefficient processes or poor feedback loops can create delays that lengthen time to production. So when you think about that, the goal here is to get through the annotation process and have the right data you want the first time. So you may want to have additional processes such as extra calibration, the correct quality steps. You wanted some pre-processing in order to make sure that the data is coming through correct the first time, and you don't need to go back and say, have your data re-annotated, which can lead to not just more cost, but can lead to a longer time to production for you. The third pitfall is a lack of visibility when validating models. So an example here for, say, an autonomous vehicle would be when you're trying to understand when and why your model is failing. Let's say, for example, that my model is doing very poorly on motorcycles. So in this case, I've got 95% accuracy on my data, meaning that only 5% have incorrect labels in them. But if I was able to dig in deeper, I could actually see on that per object class that half of the actual motorcycle data is actually labeled incorrectly. And that could be leading to much more lower performance for motorcycles specifically. And in this case, you could retarget correcting them, or you could collect additional data in order to deal with this. Next is that at different stages of model development, you're going to have different needs. And so when you're in a proof of concept phase, you're just trying to test out a concept and see like, hey, am I moving in the right direction? Is that you'll have different needs than you're going to have in different later stages. So let's say I'm just trying to build a proof of concept. I'm not going to have a huge amount of data, but what I'm going to want to ensure is that that data is very high quality and relevant to my use case. I'm probably not going to focus a lot on edge cases. And my annotations, the annotations on that data is probably not going to need to be amazingly great in order for me to see if my model is moving in the right direction. In counterpoint to that, when I'm, say, training at scale, getting ready for production, is that I'm going to need a large volume of data, and it's going to need to be very diverse. I'm going to need to make sure that I'm covering my edge cases. I've got that representation, that example I was giving earlier. You want to make sure you've got that nighttime, daytime, snow, rain, glare, all of that covered. And you're going to need very high quality annotations to make sure that your model performance is going to be there. And finally, you want to build resilience. It is really impossible to predict the future. A great example of this, a real world example of this is for autonomous vehicles. A few years ago, there was this great e-scooter trend that started happening. We'd never seen e-scooters before. It wasn't a common class type that we'd been seeing. And models would likely predict these as skateboards. You can see here on the right that if you hadn't seen this object before, you've got a human standing upright, you've got a horizontal sort of object with a couple of wheel shape and a couple of circles there. Very easy to predict as a skateboard. However, the behavior of those particular objects is actually really, really different. I don't know about you, but I certainly don't see skateboards doing 30 miles per hour going up a hill or weaving in between traffic at those kinds of speeds. And so what you need to do there is you want to be looking at your production data, and you want to be seeing new trends as they come up. You want to identify them early so that you can go back and look at data you've collected to find more instances of these edge cases or new object classes and get them annotated and get them into your model and into production as quickly as you can so that you can handle this ever-evolving world that we're in to provide resilience for your model. So those are the 3 pitfalls and what you can do about them. And I do have an exciting announcement to make, is that we have actually just recently launched our platform 2.0. And I'll just share a little bit about that platform and some of the ways that it's actually helped our customers to actually get their models into production faster and in a better way. So a little bit about Sama is that we're a trusted leader in data annotation and validation. We consistently deliver over 10 million shapes per day and at 99% customer acceptance rate. And so what that really means is, you'll see those 99% numbers talked about by a lot of folks in the industry, but they're talking about quality requirements. And we do 99% quality and higher, but 99% customer acceptance rate means that when we deliver work to our clients, they're happy with the work. And so that's a really big part of what we do here at Sama, is that we really care about becoming that partner, that annotation partner for you, so that you can actually get your models into production faster. So about platform 2.0 is that we've got a proprietary three-pronged platform that scales across even the most complex use cases. So we use Sama IQ, which is human and tech-driven insights. We use Sama Assure, which is proactive quality at scale, and Sama Hub, a collaborative project space. And we pair this with our amazing human in the loop team that are really data experts in your use cases and industries. And we use that combination of those to annotate your data amazingly and get you to production faster. So I'll dive a little bit more into Sama IQ first. is that it's those actionable data insights designed to train models faster and more accurately. And a real world example is that for a customer in ag tech, we were working with them and we provided insights to help them improve their model performance. We actually noticed that there were new bug types that were actually being seen, new insects and bug types that were being seen in the data that weren't actually covered in the instructions from the client. So what we did was we proactively collected a bunch of these samples. We packaged them together in our platform, which I'll show you in a little bit. We shared that with the client and they actually changed their taxonomy to be able to observe these new types of insects, making their product in production even better than it was intended to be. Next is Sama Assure, and we have the industry's highest quality guarantee, supporting up to 10 billion annotation points per month. And an example of here how we focus on that quality is that we optimize the quality for a faster time to market for a client. So we're working with an automotive client on a autonomous vehicle, and we were going through providing very high level quality annotations, you can think of like pixel perfect painting of an image. And we were spending that time on non-relevant regions of interest, despite that being the instructions. So they said, yes, we need every pixel to be absolutely perfect in this image with the right class identification. And what we did was we proactively said, well, hey, we just wanted to check with you. We don't believe that these are part of your goal of your model of annotating, say, things up on a balcony or buildings that were very tall. Do you need that same quality requirement on those areas of regions of interest in the image? They actually we collaborated and changed the instructions, and we were able to get them more data for the same price, which allowed them to get to market faster with a better performing model. And finally, Sama Hub. It's really our command center for annotation, validation, quality review management, and reporting. So it's really collaborative, and by collaborative space, we mean amongst your teams, but also with your annotation team, and it allows you to manage your project and provide feedback. So you can start, monitor, and manage your projects. You can review edge cases. So as I was showing in both the bug example, but also earlier in the presentation when I was talking about know what your edge cases are and how do you actually view them. Don't forget the only team that actually sees every piece of your data is your annotation team. And so being able to have a product that actually has an inbuilt capability for that team to gather the insights from the people who actually see your data, collect them in a way that can provide those insights to you, can be very powerful. We also use that for having conversations around instruction gaps. As I was discussing in how we provided enhanced quality and throughput for a client, is that feedback also has a place to live here where you can have that collaborative workspace on your time when it makes sense for you. And then you can also evaluate annotation quality and ensure alignment on requirements straight from our portal here, whether it's sampling the data, whether it's doing quality reviews, whether it's seeing how your instructions are coming to life and making sure they make sense. That can all be done here. So that's Platform 2.0. I want to thank everyone for taking the time to come to the webinar today. And don't forget to visit sama.com to learn more. Thanks so much. Lisa?